Okay, thank you. Thank you for joining this conference. We are Mrs. Carmela Canonica, Frank Daams, myself, both EFTICO, and we are just your hosts for today. So we have the honor to present some real achievements within Europe from the TNITS Go project, which is a CEF-related and subsidized-related implementation project carried out under the European Commission umbrella within the TNITS Association and EFTICO. Speakers are today Christian Kleine, President, so we have the honor to have the President inside our crowd here, Mr. David Russell from UK Authority, Leen Bakelands from Flanders region and Belgium, and Stamatis Mangianaris, unfortunately for some serious case of an earthquake in Greece, he is represented by Georgios Drenakis, which is representing him today. Finally, we have also Mr. Verdes Mati from Hungary. I'm going to give now the floor to our president, which is President Christian Kleine. But before that, I want to throw your attention to a few points. First of all, since this is a presentation, so make sure that your microphone is silenced. Make sure that this webinar is being recorded and the name of the organization of the attendees will be disclosed to reporting of the TNITS Go project to, for instance, the Commission. The recorded session will be available on the TNITS website, and the link is given in this slide. And all live attendees get a copy of the presentations that we are going to show. At the end of the presentations, there will be a Q&A session, which is at the end of the slide. So, how you can pose a question in this Q&A. During the sessions, you come up with an idea. You can put it under the presentation and send your question here. Like you see at normally at your right of the screen, you have this question section where you can put your question. And during the Q&A session, on top, you have your hand that you can raise and ask your question if you want to do that in the Q&A session at the end, after all the meetings have been done. Finally, we have also a lot of information, which is all this is on the website, www.tnits.eu, and then the previous webinars and some other information can be found there. So the agenda is my welcome, which is going on right now. We have the introduction by our president, UK, which is going to present by David Russell on realizing a countrywide data availability. Flanders is talking about moving, a tool for supporting efficient and on-site data collection. And Greece is presenting smart implementations and EU cooperation. While Hungary at the final, but of course, last but not least, ultra-fast implementations of the country, which are, let's say, going to be presented to you. And then afterwards, we have the Q&A session going on. Okay, Mr. President, I'm going to give you the floor, but before that, I give you a short introduction. Christian Kleine is manager of the data acquisition, leading initiatives in open data and public-private cooperation. He is the president of the TNITS platform, and which is an innovation and implementation platform under EFTICO umbrella. He has 15 and more years of experience in digital mapping, and he has worked with many projects in cooperation with the public sector. Christian holds degrees in geography and economics, so he's an excellent speaker to introduce to you TNITS. Christian, the floor is yours.
Thanks a lot, Frank, and also welcome from my side to this webinar. I would like to give you a short introduction about what TNITS is, and then especially our project TNITS Go, where we see today some success stories from. So, but first of all, what is it all about? So TNITS stands for Transportation Network for ITS, or Intelligence Transport Services. and it's all about exchange data about exchange road data. So all kind of static road data attributes, so such as signs like speed limits, as you can see here, or restrictions or other warning signs. And this data is used in digital maps, so especially, for example, in maps from map makers like TomTom and here. What is the position and role of TNITS inside the digital mobility infrastructure? So TNITS is really concerned about what I tried to explain before, about digital maps base layer data. So as you can see here in this circle, it's all about this data is coming from road operators or public authorities via the national access points in a standardized format, which is TNITS, going to service providers and then reaching the data user or road user. And especially one point I would like to, or one thing I would like to point out is that this data, which is coming from the road authorities or public authorities, is really reliable, fresh, and trusted because it's coming directly from the source, and the service provider do not need to catch all the changes themselves. So it would be a much faster way. What is the story of TNITS? So TNITS is already a long story. It was founded 2013 as an Ertico platform. And we had already several projects like the transportation pilot in the beginning with operational services in Norway and Sweden. Then there was TNITS was part of a sub-activity of the EIP project, sub-activity 4.7, where we started also pilot implementation in 5 new member states. In between in this time, we also released a technical specification for TNITS, which is a technical specification maintained under CEN. It's, as you can see here, technical specification 17268. And now since 2018, we have this TNITS Go project running with 9 additional member states. So in total we are looking forward to TNITS services in 14 EU countries. A little bit more in detail on the TNITS Go project itself. So we are having 20 partners. It's a self-funded project with a 2 million euros grant running for 4 years. So this year will be the last year. As I said before, we are looking for operational or at least pilot implementations in 14 member states. Minimum coverage is what we are aiming for is the 10T network, but we're also looking forward to have more geographical coverage. Also, we are implementing the feedback loop from map providers and working on new features. So, and this should be enough for introduction. And I think now we should move on to the real success stories from the countries. Thank you very much. And I hand over to you, Frank.
Thank you, Christian, for this excellent clarification of the TNITS. I now want to give the floor to Mr. David Russell from UK. UK's TNITS realization shows off by generating consistent and accurate map data in a diverse authority environment. So David is the principal geospatial consultant for transport at Ordnance Survey, working closely with the UK government on many transport policies and activities. He has over 35 years of experience, gaining a comprehensive range of technical geospatial skills and attaining the status of chartered geographer. David also represents Ordnance Survey and British Standards Institute of various ISO, ITS working groups and other transport bodies. So you're probably the most excellent person to explain what's going on in the UK, David. Go ahead.
Thank you so much. Hopefully everyone can see my screen okay. Can someone confirm that? Brilliant. Okay. So hi there, everyone. Dave Russell from Ordnance Survey. Over the past few years, Ordnance Survey, as the national mapping agency for Great Britain, has been working closely in partnership with the Department for Transport and Geoplace to develop 2 TNITS projects, as well as raising awareness within the transport sector on the need for publishing authoritative road safety information in a standardized format and structure. The first project under the TNITS banner was a proof of concept where we took a limited amount of data from 2 local highways authorities and converted this to the Rosette specification using Snowflake Go Publisher. We then built an API on Amazon Web Services and published that illustrative information to a limited audience to test the outputs and accessibility. As part of the subsequent TNITS Go project, we developed the proof of concept service further. We added additional information from other local highways authorities and used Safe Software's feature manipulation engine as the extract, transform and load process to generate the XML outputs. We again used Amazon Web Services to publish the data through both a catalog and a query dataset endpoint. As there was still only limited data available from the highways authorities, we also wanted to test the scalability of the service, so we supplemented the data with elements of Ordnance Survey's highways data. The final deliverable from the project was a web-based demonstrator. This application visualized the data that had been used and provided different ways to look at the inputs, either by date or by feature type. It also provided direct access to the API endpoints. All these outputs were shared with the TNITS community to get feedback on the platform and service. Yes, there were a few things that still needed resolving, but the outputs were readable and usable. So from the 2 projects, we've established that it's technically possible to create a data flow from the multiple sources and output that intelligence consistently and in the correct format and structure. However, the solution developed is only practical if the data inputs are consistent and complete across Great Britain. Currently, there is no consistent source of local authority traffic regulation order data that allows us to effectively manage, maintain and publish changes to road safety features effectively. From the limited traffic regulation order data provided in the projects, features such as speed limits have been captured in many different ways, sometimes as polygons defining a speed zone, sometimes as linear features that may or may not be topologically structured. It should also be stated that the data used to date has come from local highways authorities who are acknowledged as having the best data available. There are many others who still do not capture the information as spatial data, but only as textual documents. Direct influence on how spatially referenced traffic regulation orders are managed, maintained and published in the future. As a bit of background, in the UK, traffic regulation orders are legal documents that restrict or prohibit the use of the highways network in line with the Road Traffic Regulation Act 1984. They help manage the highway network for all road users, including pedestrians, and they aim to improve road safety and access to the facilities. They include, for example, speed limits, on-street parking, one-way streets, installing cycle lanes, widening pavements, etc. The majority are currently paper-based with few in digital format, and there's no legal requirement for them to be spatially referenced. Today, approximately 50,000 traffic regulation orders are published per annum, and they vary between descriptive PDF and fully spatially referenced. As I've said, currently there isn't a consistent way of getting consistent authoritative traffic regulation order data from local authorities. However, through GeoPlace and the supply chain and governance for the collection of addressing and street information from local authorities, this does exist, and this could be extended to include traffic regulation order data. As a consequence of the findings from the TNITS project, the Department for Transport embarked on a holistic discovery project into all aspects of the traffic regulation order process, both from a data management perspective, but also from a legislative perspective. Traffic Regulation Order Discovery Project was formed when the Department for Transport, British Parking Association, Ordnance Survey and GeoPlace came together. The partners agreed to support each other to deliver 3 important aims in a joined-up way. Firstly, to engage widely with the TRO experts and those who require traffic regulation orders to consider how well the process works and how it might be modernised and improved. Secondly, to produce a guidance to help local authorities understand how they can work within the limits of the current legislation based on best practice. And finally, to produce a draft data model for traffic regulation orders. The starting point for this data model is the TNITS model. This was used to ensure that the authoritative information captured and maintained by local authorities could be easily published through recognized channels. The data model itself was extended to include all types of traffic regulation order in the UK, which include on-street parking and parking restrictions, as well as orders for vehicles moving around the road network. It also provided flexibility so that both legal definition as well as the effect on the traffic could be described in consistent ways. The partners also sought to address the recommendations of the independent DFT consultation by North Highland, looking at local authority data discovery, which found that traffic regulation order data is difficult, time-consuming to access, clean and process. Traffic regulation order data is not in a standardized machine-readable format. The process for amending and implementing a traffic regulation order is labor-intensive and time-consuming. So the discovery project has now moved forward and a subsequent alpha phase has been released. One of the key goals of the project has been the creation of spatially referenced traffic regulation orders based on Ordnance Survey detailed geometry and to make them available under an open government license. So that's the journey we've been on. There's still a long way to go. The ecosystem for the collection, maintenance and publication of authoritative road information is a complex one and has many interested parties and initiatives. But TNITS has a key part to play in ensuring that information is published in a consistent way. The platform we've developed has raised numerous questions and will be an integral part in delivering appropriate solutions and gaining an understanding about how the architecture around a central traffic regulation order hub and the national access point should evolve. The TNITS Go project has highlighted the deficiencies around the current data situation in the UK, but it is also driving a determination to deliver consistent, standardised data. And that's it for me. Thank you.
Okay, David, that's a wonderful presentation. Thanks for presenting the UK's TNITS achievement in this diverse landscape, I would say. And now we are moving on to Mrs. Lien Bakelands from Flanders, Belgium. She presents the mobile app and Moving, which is a fast and efficient production tool for accurate and consistent data collection. Mrs. Lien Bakelands graduated quite recently, 2015, as a geographer at the University of KU Leuven, which is in Belgium. She worked for the city of Antwerp, gaining a good understanding of local authorities' needs and their dynamics. Since 2019, she joined the Flemish Road Authority as an external business analyst. Her work focuses on the coordination of developments of the existing application Verkeersborden Vlaanderen. So this is Dutch for the English. I translated to Traffic Signs Flanders. Yeah. And the Moving app, MOVIN, application and for the optimization of data transfer in TNITS. Lien, I guess we are all waiting for your inputs.
Okay, thank you for the introduction. Can you see my screen?
Yes, we can.
Okay. Good afternoon, everyone. I'm going to give you some more information about our TNITS Go success story of Flanders, the Moving tool. It's actually an abbreviation of a longer Dutch name, but I will spare you that. In English, it translates loosely into a tool for supporting efficient on-site data collection. So first, I will talk a bit more about what we did these past years. So we published a large set of safety features in production mode. First, we focused on the speed limits and on the speed on signs with speed limits. Then we also expanded this to restriction and warning signs. You can see a number of examples here on the slide. And then at the end of 2019, we launched the mobile app Moving. And we focused there first on tablet devices because we assumed that that was the most convenient to go on site and then you have a bigger screen. In 2020, we monitored the service, the performance and the stability, and the results were quite good. We also optimized the service at the request of our partners. they had some issues processing the information, so we added some more attributes that would make the processing easier, and we also aggregated the changes in the service. We also published the service on the Belgian National Access Point, transportdata.be. I added the link here in the PowerPoint. Finally, we also adjusted Movin, that it's also easy to use on a smartphone, because we got some feedback from the users that they also wanted to go on terrain with a smartphone with a smaller screen. So these were especially user interface optimizations. What were the main challenges we had to face? So for deriving the speed limits, we use two data sources. The first one is the official Flemish transport network, and we encountered there some inaccuracies. So we use for our algorithm driving directions and also morphology information. For the driving directions, we learned that they were only present for the major roads, not for the smaller ones. And the morphology we use, for example, unpaved roads and private roads. We don't use them in the algorithm, and this information was not always correct in the network. So that caused some issues. Secondly, we also use the traffic sign database for Flanders, and this is the responsibility of all the traffic, the road authorities, so both the local authorities as the Flemish road agency. They so it's their responsibility, but not everyone was really updating their database. So we spent some time putting together workshops, trying to let them see what the advantages were of using our database, but they gave us the feedback that they don't always have the resources to update this. So they asked us, how can we inspect all these traffic signs in our municipality in an efficient way? So the information was outdated, and they asked us how they could update this, because they were going on site with a paper map and a pen and were just writing on the map what was wrong and what needed to be adjusted in the database. Secondly, they were also using other external software to capture these problems, but here we had some difficulties of getting this information into our Verkeersborden Vlaanderen application. Then we propose a solution, the mobile app Movin, which is a very easy to use, user-friendly app where you can make these inspections and send this information to the existing application where you can efficiently process these changes. So here you can see how the mobile app works. So you can zoom into your location, click on the traffic sign in front of you in the database, and add a picture, and also add some remarks or say what is wrong. And you can also change the background map. But that's it. So it's a quite easy to use, simple application. We also got some feedback from the users that they wanted to send student workers or people without the proper background knowledge on site to do these inspections, and then someone else with the authority to change the database process the inspections. Then what were the results of our efforts? So on the map, you can see in blue the municipalities that were working with our application. The hedged regions, they have their own external software. We are talking to them to get them to set up a synchronization that we can also use their data in our database and algorithm. But you can see that in 2018, that was the year after the release of the existing application, that there were still a lot of white municipalities. And then in 2021, you can see that Flanders is turning blue. So this was what we were trying to accomplish. Then below on the slide, you can see the amount of users. We calculated this with Google Analytics, and you can see the trend of move-in. So we launched it at the end of 2019, and you can see especially the peak in April 2020 because of the COVID-19 lockdown in Belgium. There were a lot of local authorities that were looking for new tasks for people that couldn't do their regular jobs. So actually for our database and data quality, 2020 was a good year actually. Then what are our future plans? So we want to further bridge the digital gap between on-site inspections and an updated database. So our vision there is that we just send someone on the streets with a smartphone or with a tablet and take a picture of a traffic sign, and that is then automatically updated in the database. So that is our future vision. We're obviously not there yet, but this is what we are trying to accomplish. Then in this year, we also want to implement a new standard for the TNITS service, and we want to start a redesign of our existing application, because we launched it in 2018, but it was already adjusted from another existing application that was quite old. So we want to improve the data model and tackle technical debt, and keep, of course, all these existing users on board, because we did some effort to get them on board. So we want to make sure that lasts, and also keep on attracting new users, because this is, of course, good for our data quality. Thank you for listening. I also added here our TNITS contact, Bert Boterberg. If you have any questions, you can send them to Bert. Thank you.
Thank you, Leen. Thank you for this Flanders contribution today and your future vision in this fast digitalization, and certainly also in relation to the TNITS purpose. The more data we have, the better it is.
Okay.
I'm now moving to Mr. Georgios Drenakis, representing, in fact, Mr. Stamatis Mangianaris from Greece. His presentation shows smart implementation approaches that lead to an effective and timely TNITS service provisioning. To give a kind of background of Mr. Georgios Drenakis, he received his diploma degree in electrical and computer engineering from the National Technical University of Athens in 2012. He is a Master in Science in Wireless Optical Communications from the University College in London in 2013. And he has 6 years of experience as a software engineer with various projects on embedded systems, mobile telecoms, logistics, and industrial production. He currently works as a software engineer at the Institute of Computer and Computer Systems, ICCS, many knows those. His main research interests are wireless communications, mathematical modeling, Windows application, and agile development. We are looking for your agile presentation, Mr. Georgios. Go ahead.
Hi, hello, good afternoon. Hope you can see my screen.
Yes, we can.
Okay. So, as Frank said, I come from ICCS. My name is Georgios Drenakis, and today's presentation will be about the TNITS implementation for the Greek pilot. As you know, TNITS is aims to build a reference interface for European road data updates, and for the Greek pilot, which is related to Greece being an immature country in terms of intelligent transport system, ITS. We aim to build a network of collaboration between different authorities in order to distribute these road attribute changes that are needed by the map makers. As you can also see here, in comparison with other countries such as Sweden and Finland that have already some running services implementing in advanced features, Greece and other countries were relatively new. So we have to make a lot of adaptations and plan and use the help of more mature or champion countries in order to catch up with them and try to make our service run. During that process, we faced a lot of challenges, mainly because of the fact that a lot of other supporting actors of this tool chain were not ready, or we couldn't cooperate in technical and not technical aspects. I have gathered here the most important challenge that we have faced. So the Greek National Access Point was under development for the duration of our pilot. So to deal with it, we had to make some adaptation and implement a NAP emulator in order to test our datasets. Also, the raw data format of the datasets was very different from TNITS protocols, so we had to implement some translation services to actually translate the data into the protocols as posed by TNITS. And also there were other non-technical features such as administrative and legal issues that we had to solve by collaborating with public authorities such as the Ministry of Infrastructure of Greece, MIT, and also the institute that holds the National Access Point, IMET. Aspects such as licensing and security issues that again we had to deal with trilateral agreements, and also by the fact that not a lot of data was available in order to perform the tests, so we had to make our own synthetic data to go on with our implementation. Here is the final architecture of our of the Greek pilot. The main data provider is Egnatia Odos, which holds the traffic data. This is in a custom format, so we had to implement a middleware service by ICCS, which was responsible for the translation and the exportation of data to the to a cloud server that was hosted by the National Access Point, NAP, from where the data is available to any end user or map providers. Currently, the implementation is finished. The whole system and the toolchain is deployed, and we are going through, I'm sorry, an evaluation process by the map makers in terms of the data content and accuracy and data format in general, which is expected to end by at the end of this year, where the project finishes. In regards to the geographical coverage, so far we have only implemented this into the Egnatia motorway VA-A25, which is the yellow line depicted in this image here. It's in the northern part of Greece. And at the moment, it's only limited to this highway. It's a 96-kilometer double carriageway with 2 lanes, and the data includes some traffic signs in terms of speed limits and toll stations. So it's very limited at the moment, but we expect to expand in the future. And actually a very interesting outcome of the project is that the Ministry of Transport is implementing a feasibility study in order to extend our results and all the experience gathered for other road networks in Greece. An important aspect of our implementation was the collaboration and coordination with other consortium members and other members of the Greek implementation. Since we were Greece was a relatively immature country in terms of ITS. We needed the support from these champion countries that had a lot of experience in implementing such services. We received some very well documented guidelines. Also, there were some Q&A sessions. There was live support by countries such as Cyprus and Finland. And also, there was always a progress and evaluation monitoring. In terms of collaborating with Greek authorities, we had to organize a lot of technical collaboration meetings between ourselves, ICCS, Egnatia, which is the data provider, and the ministry, as well as the IMED that holds the national access point. And of course, we had to have some communication links available at all times in order to solve any upcoming issues. In regards to our future plans, currently the TN-ITS pilot is deployed, and we are on the testing phase and the evaluation by the map makers. In parallel, the ministry is in charge of performing a feasibility study for future extension. And we are in some kind of a bilateral discussions as to how we will expand the results of our work for future in future projects or in some future studies. We have already discussed some aspects that we could work on, such as the expansion of road networks or adding of new traffic elements or new attributes per our existing elements, because so far, as I mentioned, the elements are limited. Thank you very much.
Thank you, Georgios, for showing Greece's solutions on how to quickly introduce TN-ITS implementations. Really great work. And now it's time for our final speaker, which is Mr. Verdes Matti from Verdes from Hungary. And his presentation shows how countries can introduce TN-ITS services in a very short lead time. To give a background, Mate Verdes is working as a head of ITS department in the Hungarian Public Road Company, and with an economist and licensed accountant background, he specializes in project management. So Mate is working in the field of transportation since 2016 and is really committed to improving road safety and improving traffic efficiency. He's interested in cooperative, connected and automated mobility technologies and solutions. Since 2017, he's a member of the ITS Hungarian Association and he took part in several working groups, example, Connected and Automated Working Group of CEDAR, PIARC in the Technical Committee 2.4 on road network operation, intelligent transportation systems. So, Mate, show your commitment to TN-ITS and how Hungary moved on. Go ahead.
Thank you very much for the introduction. After hearing these good practices before me, let's continue with a short presentation how can speed up the map data exchange small countries, national road operator can do from scratch. Thanks to the first phase documentation and the standardization, large set of documentation were available, and we can easily develop our services. First of my presentation, I will talk about who we are and what we are doing in general. Then I will highlight the main challenges we had to face during these years, and we can discuss about it later. Hungary plays an important role related to the transit traffic in Europe. Most of the TEN-T network in Hungary operated by the Hungarian Public Roads Company. Our main responsibility is to ensure safe and economical and convenient traffic condition for the road users. The everyday activities include winter maintenance, road patrol services, detection and repair of road defects, maintenance of machines and equipment, and quality control activities as well. Approximately 32,000 kilometers of public roads operated by us, including more than 7,000 bridges. To conclude, the company is an important actor in transportation in Hungary, and in order to make our roads more efficient and more safe, we work on the digital services as well. We provide as much information as we can to help the drivers planning their route or support them during their journey. We believe in a connected ecosystem where the advanced data exchange plays a very important role to the transportation, and it can be enhanced. A couple of years ago, the traffic signs on our roads were registered several different ways. For example, on paper, and it was scanned and stored in a PDF document. And a non-organized database couldn't be precise enough, so we had to find a solution how to ensure the needed level of data availability and quality. There were some legal boundaries as well, because the traffic signs and road marks registration and modification has a legal aspect and had to be accepted by other stakeholders, for example, the local police or local authorities. The main challenge was at first to build a proper traffic sign registry, which can support legal and other administrative process. The Hungarian TNITS service has now two main data sources. First, National Road Database, which contains weight, height restrictions, and speed limits, and many other linear data. The newly built registry for all the other traffic signs is the second and one of the most important data source of the TNITS service. Our job now to extend the shared map information, and we are working on it continuously. In parallel, the TNITS interface development, a data warehouse type national access point has been built, and the TNITS service was introduced as an integrated and very important part of the national access point. We are happy that our work was eye-opening for municipalities as well, because there are initiatives, a couple of them, to join to the TNITS service and share the same level of information and with same quality that we are sharing right now. Some of them are committed because they have seen how far we can go in only 24 months from the start. So thank you very much for your kind attention.
Yeah, thanks, Matti. That's of course much showing how fast the TNITS can be implemented in, I would say, in an existing environment, but a lot to be modified to do, and it's wonderful in the time achievement that you did. So thanks a lot for that. Yeah. Today, I think we are moving now to, let's say, the questions and answers. There is a large amount of people on the scenery we see, so there must be also a lot of questions. And I think the first question that we saw, or maybe one of the first questions, is to Lien from Flanders, and the question is, on moving, people ask if the application is available for general purpose or for an example map maker.
So Now today, it's actually the access is arranged by the local authorities themselves. So they can give access to everyone they want to that is making these inspections. So for examples, people, student workers and people like that can get access. But we are also looking into a way to make it more publicly available. But the bottleneck there is that in the existing application, someone has to process all these inspections. So there we are still looking and asking our users how to handle this efficiently. So from now on, it's still only the municipalities and the Flemish Road Agency themselves that give the access. So it's not just publicly available.
Okay, thanks for the answer. We have also a question for David. I guess you mentioned somewhere, according to the public, that there was a licensing data has been mentioned. If it's consistent, standardized traffic regulations orders database on detailed ordnance survey data is the intention, then surely that information will always have licensing restrictions. So can you comment on that, David?
Yeah, absolutely. So I think this has been one of the challenges in sort of the United Kingdom for some time, and obviously some of the conversations we've had sort of within the TNITS community around making data openly available in the United Kingdom. Obviously, sort of the actual local authorities have access to ordnance survey data and want to utilise that sort of detailed information as much as possible. But obviously, sort of that requires licensing, sort of, and I say they've got a collective agreements for use for the public sector, but that's not for commercial gain, etc. But just within the last few weeks, Department for Transport has made a successful exemption request to allow all future traffic regulation orders based on ordnance survey data to be published under an open government license. And that's obviously dependent on sort of third-party data or third-party IP within that data. But it basically means that sort of moving forward, all highways authorities should be able to publish their data in as open data and made it openly available to anyone and everyone.
Okay. I hope this is quite okay for the audience. Georgios from Greece, I have also a question to you. Yeah, you faced a lot of problems, but what was, according to you, the most difficult challenge in your pilot?
Okay, that's a bit tricky. I guess the most challenging part was not the technical aspect of implementing the TNITS as a service, but mainly non-technical aspects in regards to legislation, legal issues, I mean administrative, and how to collaborate with all these various partners, Egnatia that holds the actual data, the ministry that has okay, it's in the public sector, there are some restrictions and all the communication links we had to establish between all of them, and of course the national access point and when and how it would be implemented, because it's currently on a beta version. So I would say yes, the most challenging part was the collaboration between all the different partners in an immature landscape such as in Greece.
Okay, I even have a second question for you.
Okay.
What was the pilot highway data format, and how did you accomplish the translation to the uploaded format or to the NAP?
Okay. So the raw data was that came from Egnatia was in a KML format. It was a custom, actually a custom-made KML format by Egnatia that helped them do the visualization, and via our translation service that was implemented and translated and formatted as a XML file according to the TNITS protocols. And this is actually uploaded in the NAP for the end users.
Okay, thanks. if the audience has more questions, they can still look at it. Christian, maybe I ask a question to you, if I may. I guess you lined out the current situation of TNITS, but how do you see the future, and especially related to the NAPs, the national access points?
Yeah, so I think we would like to see TNITS on the national access points. Yeah, to have the national access point as one place to go for data users for road data or TNITS data. And so not sure if this answer your question, or have you understood?
Yeah, definitely. I mean, the NAPs play an important role, I guess, to TNITS.
They are one part of the digital infrastructure, and then often called as the backbone for mobility data. So, of course.
Do you think that they have a big role in the accessibility of the data? Because today, many countries have TNITS related to a link, like just a web link, I would say, and then you can access the data. But of course, you must know the link. So.
Yeah, I think, and here the national access points play an important role, because then all data users have really a go-to point where they can find the data, and also have clarity on terms and conditions, which is for reusing data always important to have clarity on which terms and conditions you can use the data, and also more indication on quality and freshness.
Okay, thanks for this answer. And I have also a question. We do all the speakers here, just by coincidence, I guess. Mate from Hungary, the question is the following. You had a wonderful accomplishment now in Hungary. So what is your future vision?
A future vision is to convince most of the municipalities to join to the TNITS service, and expand the shared categories of the shared data, and to monitor the quality and the availability of the data.
Okay. Thanks a lot, Mate. I see another question coming in. Let me point it. In the future, this sort of road sign and speed limit data will be accessible by autonomous vehicles, or is it mostly intended for the authorities to use? Maybe one of the speakers can answer that question, or can give a feedback to that. David, what's your vision on that?
Bear with me a second. So could you just repeat the question again, please, Frank? Sort of now, just so.
Okay. So the question is the following: in the future, this sort of road and sign speed limit data is also accessed by autonomous vehicles. The question is this true, or is it mostly intended for the authorities to use? So the question is it for authorities, or is it for autonomous vehicles, or maybe both?
I think the answer is both. I think sort of one of the challenges that we face in the United Kingdom is, I suppose, differentiating that authoritative view that's actually held within the legal documentation, and actually sort of the representation sort of through the signs. The signs don't necessarily correlate 100%, and obviously once we get into that whole world of autonomous vehicles, there has to be consistency, and therefore I think making sure that the signs represent exactly what is in the actual the legal definition there needs to be a process to reconcile that information far better than there is today. So I think there's definitely space for both, but I think having sort of consistent data will enable that consistency and harmonization of the different aspects. Okay,
David, that's a wonderful answer, I would say, and making sure that there is room for both. It's nice to know, and also the role of the NITS in this world. Then there is another interesting question about recognition of the people saying, okay, thanks for all these successes. Yeah, of course, there are in every country, there are specifics to be solved, and it was definitely also shown by the UK. But there is now a specific question about Germany, and I think we have a German in the panel. So the question is, what are the major roadblocks for the other countries like Germany not to be part of TNITS today?
Good question. So that I'm not really a representative of the German public authorities, I can more or less only speculate or tell you what I think from my discussions with the public authorities is it is especially the different states and different responsibilities for roads. So this is one major block. So owner of data is really fragmented on data ownage, and so this is one of the biggest roadblocks, I would say, especially for Germany, and also data generation is still something, because still today a lot of municipalities they don't have this data in digital format available. So I think this would be this step needs to be the first to implement then TNITS in a second step. So you need also some data to start with. So there are different reasons, I would say. I cannot hear you, Frank. Frank, I cannot hear you. Maybe you're on mute.
Hello, Frank. We cannot hear you.
So what I wanted to compliment, sorry for that, is that that we see that TNITS implementation itself. I'm as the coordinator of TNITS Go, I see that happening in many countries. That TNITS implementation itself is a good reason to start collecting data in a more modern way, like Flanders, for instance, did with the moving app. We also have a question that maybe I can address. The TNITS model allows several location referencing methods, OpenLR, geometry, linear referencing, external references. And of course, it's interesting to know what has been implemented in the several services. Yeah, I assume that it's a little bit, if I may say so, a little bit outside the scope of this because of this webinar, because we can then ask every country, but it's good to know that in the list of references that we have on the website, there is also what we call visionary progress monitor. It's a kind of file that explains how every country moves forward in the data acquisition and the data sharing, and there you see, let's say, all these references, what are being used for the countries and what are not. Within the project itself, we have a kind of priorities, of course, related to, for instance, traffic signs and in particularly the speed limits, which are a little bit of priority in the project. But of course, it's every member state's own choice to set priorities and to implement them at this moment. I'm looking to other questions here. I think we are almost done. Any comments or any other information? And otherwise, Carmela, I think you can have the last word.
Hello, Frank. We have actually two additional questions here. So one is for David Russell. So the question goes, I was wondering if Brexit changes the role and the commitment of the UK to the TNITS platform.
Nice question.
It's a very good question. From our perspective, and I suppose really sort of I'm speaking on behalf of Department for Transport here, I don't think it does. We're still fully committed to it. We're still fully committed to the development of the NAP as well. So I think we are going to remain actively involved in all the initiatives. Obviously, sort of, some of the actual logistics around that might be slightly different, but there are obviously other members sort of, of the community who aren't actually members of the EU either. So no, we'll still be here for the long haul.
Okay, it's very good news for all the people that like to have the data. Camilla, next question. I lost it a little bit. Maybe you have a next question.
Yes, I do. Are there some potential application for augmented reality with roadmap data? So maybe this is a question for map makers.
Yes, and there are already some applications, for example, showing the signs in real time, and then this is some kind of augmented reality. So that's showing the location of signs, for example, in your windshield. So there are already existing applications, and but especially when it comes to application, I think one of the most important upcoming applications is really eyesight, which is not automatically augmented reality, but it shows you, or should show you also in real time, the actual speed limit, and this can really be supported by road data and map data.
Okay, clear answer. So a lot of potential in the future, and I think we will see more of this digitalization going on. My list is empty, Carmela.
Yeah, no, we only have the last one, the last question. I still have something for
our. I think all the questions to the ladies.
So I have a question for Flanders. We ask if you can describe how the mobile app was developed and how you involved the different users.
Okay, so our approach was a bit lean and mean, as they say. So we did a workshop to involve all the different users, and we asked them what was actually the minimal usable product. So we wanted to build something very fast and really focus on what was the most important thing for our users. And we also then developed it and launched it as a beta version, and then it was tested by a number of users, really in a way as if they were really using it. So it was also a big test with the actual data, and it went great, and everybody was very positive about it. So that was actually our approach.
Yeah, Lean, it looks to me like a real startup, successful startup, I would say.
Yeah, a little bit.
In fact, knowing I'm also responsible for the startup community in Ertico, so welcome. Okay, Carmela, if you have more questions, then we are happy to go on.
No, that was actually the last one that we have. I will politely kindly ask our attendees if they wish to pose another question, either to raise virtually their hands, or yes, we have no. So if you have any last question, we will take it in the next couple of minutes. Yes. So is there any focus on real-time data being added? Maybe Frank wants to take this question. All right.
Yeah, I can do that. Yeah, so that's a good question, because real time is a big issue, but a big opportunity as well. I mean, every issue is an opportunity. So how do we look at it? I think more than 2 years ago, when we had an assessment of the NITS data, it became clear that we are of course looking for freshness. So the map updates need to be as quickly as possible, because then the right data is at the right at the right place, at the drivers or at the applicants. So that's clear. So we look also that, yeah, for real-time data, there is a specific protocol, which is DATEX2, which is, let's say, complementary to TNITS. And if you look into the old, let's say, Commission documents, then TNITS is mentioned as static data, and DATEX is, let's say, indicated as dynamic data. But rightfully, and since we are looking for more and more freshness, of course, we are looking to more and more dynamics also in the static data. So the insight is more that the difference in the two is that we look at TNITS as the base layer of the map. It contains all the materials that are part of the attributes of the map, and it's about the update of the attributes of the map, where DATEX is about the real-time traffic information on top of the map. So we call it a service layer. So maybe these are more modern names, and these are not really official yet, but we like to push them around because, yeah, the difference between dynamic and static is going away, because everything in this world is going to be dynamic. And so we are more talking about, let's say, the data related to the base layer, map-related elements. And maybe even in the future, it's not only about maps, but even like David also mentioned, for automation and for applications like speed adaptation or speed advice, intelligent speed advice. The data is, of course, there available to support these applications as well. So we are seeing also in countries like Finland and other countries that the data is consumed by other consumers than just map makers. So yeah, it's a general data sharing format that can be used for, let's say, a lot of applications that you have in mind. Thanks for the question.
Thank you very much for the answer, Frank. I would add on that static and dynamic, the difference is we would think about it more like permanent versus temporary, sort of difference.
Rightfully.
Yeah. Okay, so this was it. I cannot see any other fresh questions. So I would want to thank all the panelists and all the attendees. And I'm sure Frank joins me in thanking you all. And and we hope to see you again to our next webinar. We will let you know when this will be. And we will, of course, provide the presentation to the attendees of this webinar, and the recordings will be made available online as soon as possible.
Okay, thanks a lot.
Perfect.
And
thank you very much. Thank you. Bye-bye.
Bye.
Thank you very much. Bye.